Welcome to Equity Builds Expertise, the podcast. Because whether you teach it or build it, expertise grows where equity leads. I'm Shana Buckner, STEM educator, consultant, author, and the voice behind the Equity Builds Expertise framework. And after years of helping teachers, school leaders, engineers, and technical teams grow their people, I've learned something pretty simple. And that's that classrooms and companies really face some of the same challenges. And it's going to be the same solutions that change everything. So here, we're going to talk about what really builds expertise. We're talking about belonging, access, agency, clarity, communication, and those everyday decisions that actually shape how people think, learn, and collaborate. So if you're committed to growing your people, whether we're talking about students or staff, teachers or engineers, then this is the space for you. So pull up a chair, grab your notebook, and join me as we bridge the worlds between STEM education and STEM industry and build the expertise that truly lasts. This is Equity Builds Expertise, the podcast. Let's get started. Welcome back to the Equity Builds Expertise podcast, because whether you teach it or build it, expertise grows where equity leads. Okay, so in our last episode, we talked about how we actually see students and how that is going to shape what we believe they're capable of. Today, I want to make this all practical, because belief alone is not enough. We have to actually build access. So today's episode is about those skills behind the content, the things that we assume students know how to do, but often haven't been taught. So let's get into it. If you've ever wondered why students struggle to keep up, even when they're genuinely trying, you have to look at the barriers we aren't seeing. There's a quote by the physicist Richard P. Feynman that I think about constantly, and I actually have used this quote in many sessions. He said, "You can know the name of a bird in all the languages of the world, but when you're finished, you'll know absolutely nothing whatever about the bird." And then he said that he learned very early the difference between knowing the name of something and knowing something. That is what we're talking about today. The difference between memorizing a fact for a Friday quiz and actually building true lasting expertise. Now, we know from neuroscience and research, and Malcolm Gladwell talked about this, that it takes roughly 10,000 hours of practice to achieve mastery of anything. And so true knowledge is acquired through this deep skill engagement and practice. But how do we get our students to practice the right things? In STEM, we often get so hyper-focused on the final product that we forget to explicitly teach the process. And we expect our students or our teams to speak the language of the content fluently without ever actually teaching them the grammar. So those are some of the foundational tools that all people need and all students need. And I call them the transferable trifecta when it comes to students. It's teaching vocabulary, data analysis, and note-taking. Those are the tools that I think students need to access the content and build true independence. And guess what? Today, I'm not going to just talk about it. I'm actually going to teach you some of those skills. So let's break them down. So let's start with note-taking. Now, I want you to ask yourself two very important questions. Why do you take notes? And why do you want your students to take notes? Usually the answer is to retain information or to study later or to synthesize complex ideas. But here's the problem. We assume that people naturally know how to filter information. And they don't. Note-taking is a highly complex cognitive task. And so if we don't explicitly teach students how to organize information, they're going to just transcribe whatever's on the board or copy it out of the textbook. And we know that transcription is not comprehension. So how do we fix this? We need to make the learning constant and not the variable, right? So develop a concrete note-taking format for your class. Give them a structure. So for example, you could use a template that has room for questions or key vocabulary on the left with definitions on the right and a dedicated space for summaries at the bottom. I used a combination of the Cornell note-taking format template and like the SQ3R format. You want to create the exemplar. That's the second thing. You want to create the exemplar to show them exactly what the notes should look like. And then here's where sometimes we fail. We forget to teach the model lesson. Don't just hand them a textbook and then or a slide deck and say, take notes, which I have been guilty of in the past. You want to teach the lesson to show them how to use the textbook to create those exemplary notes. And the last thing is actually require them to use it. Create assignments where students actually have to use their notes in a meaningful way. Give them an open notes quiz where they only get credit if they can find the answers in their own notes. It forces them to see the value in the process. Okay, skill number 2, I want to talk about precise vocabulary. Science, math, and tech have their own distinct dialects. We know that. If a student doesn't have the active tools to decode the vocabulary, then they're actually locked out of the conversation before it even begins. In this book by Isabel Beck and Margaret McEwen, it's called Bringing Words to Life. And I got this book from an AP English teacher, a good friend of mine. They talk about how learning new words has to go beyond presenting the definition. So even rich explanations will not result in deep knowledge. Students need multiple encounters over time for those words to become permanently represented in their vocabulary. We need to understand that there are 3 tiers of vocabulary words that they talk about here. Tier 1 are those basic words that you usually don't have to explicitly explain and do instruction over after elementary school. So adding, subtracting. Then there's tier 2. Those are those versatile academic words like analyze, explain, or directly proportional to or inversely proportional to. And then there's tier 3, which are those specific content domain words like photosynthesis, polynomial. In order to teach those tier 3 words, we actually have to move beyond forcing students to do remote memorization. So I want to teach you one of my favorite instructional strategies. This is called the 9 square activity, and I learned it from a history teacher friend of mine many, many years ago. So if you're listening, one of the things you want to do is you can use this and take paper. You're going to take a sheet of white paper and you're going to fold it into 3 columns. Think of your business letter. Okay. Next, you're going to fold it again into 3 alternating sides. I guess it doesn't have to be alternating. But when you're done and you open it, you have 9 squares. Now, you're going to place a single key term or phrase or concept from your current unit into each of those squares. Then what happens is the task is that your students will then pick any 3 words. And I have a little template that I use. Students will pick any 3 words from that list. And it can be either diagonal, it could be horizontal, it could be vertical, that they pick these 3 words. But the reality is that they're going to explain those vocabulary words. And the only criteria is that they explain the words accurately, the definitions, and that the relationships between the words they have chosen are clear and accurate. When students have to connect words like carrying capacity, population, and limiting factor in a single coherent thought, they aren't just memorizing definitions, they're actively evaluating connections. And then when they switch papers and have to engage in a conversation around it, they are now engaging in the language of science. The last skill I wanted to talk about is data literacy. And that is the last skill that I think is a transferable trifecta skill, because numbers tell a story. But if a student or an employee cannot even read the data, then they can't participate in the solution. So we must develop a process for analyzing any graph or chart, and we have to make it purposeful for students to practice it. So one of my go-to frameworks is one that many science teachers know. It's called the CER method. C stands for claim, E evidence, R rationale. And you need to teach students how to break down any graph or diagram or chart with that. So claim, first have them develop a claim about the data that they see. What is the relationship between the independent, dependent variables, between the X and Y axis? Make a claim that is true. Evidence, they need to use the evidence from that data table or that chart or that graph to explain why that claim makes sense. Right? Why is that claim true? And then the rationale is where they start to bring in the scientific principle, the theory. Why does this claim make sense according to science? Listen, by providing students with a framework like that, you remove the barrier of staring at a blank page. You give students a roadmap to access the complex ideas that you're trying to teach. I want to remind you of a core thesis of this podcast, right? It's that classrooms and companies face some of the same exact problems. So whether you're an environmental science teacher trying to reach a struggling student or a manager trying to build a cohesive tech team, the point is that the barriers to building expertise are identical. If someone is struggling to keep up, it isn't a lack of intelligence. Maybe it's a lack of access. And it's on us as leaders and educators to make the invisible visible. Now, I know I went fast through some of those strategies in the trifecta skills that are transferable, but if you subscribe to the newsletter, if you go to the website, www.seedifferentconsulting.com. There are resources there where there are a lot of exemplars that you can download and access. And of course, as always, if you have questions around any of those skills, I am happy to share any information with you and strategies. All right, well, thank you so much for joining me today. So that's it. What a great episode. Listen, if students are struggling, it's not always the content. And sometimes it is the access point that we haven't made visible. So here's something I want you to think about. What are you expecting students or your team to do without ever teaching them how? All right. So now I'm really excited about our next episode. Our next episode, I'm joined by Art Worrell, my baby brother and colleague in this work. And we're going to dig into what it truly takes to build independent learners. If this episode is one that you enjoyed and one that you've learned something new from, share it with a colleague, share it with someone that you are learning alongside. All right, I will see you in the next episode. See you there.